Hey everyone, welcome to problem number 25, reverse nodes in K group. Okay, so it's a hard difficulty one. Given the head of the linked list, reverse the nodes of the list K at a time and return the modified list. Okay, I know hard problems are very intimidating, but we'll try to crack down line by line. Okay, and just bear with me. We just have to clear out all these test cases, and we'll be done with this one. Shouldn't be too much. We can tackle this. Okay. So k is a positive integer and less than or equal to the length of the linked list. Okay, if the number of nodes is not a multiple of k, then left out nodes in the end should remain as is. Okay, fine. You may not alter the values in the list nodes, only nodes themselves may be changed. Okay, so given an example 1 2 3 4 5 and k being 2, then we have to swap nodes in the multiple of 2. So 1 2 will get swapped and 3 4 will get swapped. Now 5 doesn't have anything, so 5 would be left as is. So the result would be 2 1 4 3 and 5. Same if you have 1 2 3 4 5 with k being 3, then the first 3 would be reversed, right? And the 4 5, because it's not in the multiple of 3, they'll be left as is. Okay, the number of nodes in the list is n. K is less than n is between 1 and 5,000, and the node dot val could actually go from 0 to 1000. Okay, so if something like this comes in, brute force approach is the best one, because anyway there would be a time crunch, and maybe you would try to complicate the things which need to be complicated, right? So we'll stick with the basics. What we can do is, sometimes the linked list operations are not very feasible given the data structure is linked list. Sometimes just keeping the list in Python would also solve the problem. You don't have to work around with the pointer and next and pointers dot next and everything. All you could do is stick with the basics. So here's what I'm trying to do. Let's actually figure out what's the length of the linked list, right? Anyway, in the constraint it says, it kind of hints us that the number of nodes in the list is n. So let's see if we can find n. So n equals 0, current now points to head, and while current, we can do n plus equals 1, current goes to currents next, right? So it will at the end, once it reaches like null, then we would figure out, like, we will get to know what n stores. That's basically the length of the linked list. Okay, what you can do in the meantime is, let's get an res array and start storing in the values as well. Okay, I don't feel like working on the pointers in the list. I'd be comfortable doing it in the array in Python. So what you can do is current.val. Fair. And now there is this range function that Python gives me, which can give you a hop of the k. So basically it's like a window function. So what you can do, k goes from 0 to n with the hop of k, right? Fair. So that's a way of writing it in Python. I'm sure there would be, if you're using a different coding language, there has to be something similar in this one. Okay, so we will do final array, and the temporary array would be this. So result from I to I plus k. Oops. Right, so now the temporary array would be 1 2 3, and this is what it is. So what we have to check, if it is in the multiple of 3, right? How would you know? So if length of temp oops, is actually equal to k. If it is actually k, then we would want to reverse this, right? So final is temp reversal of the temp. This is the Pythonic way of reversing it. And if it is not, so something like this, 4 and 5, if it is, the length is not 3 because it is 2, then we just have to append it as is. Fair? And now we have the actual list, so basically actual array in whatever the format we want, but they want the list nodes, right? That should be fairly simple. We can just create a dummy equals list node of 0 or -1, and then what you can do, while there is final, and then what you can do is result dot append final dot pop 0. Oh, my bad. What you can do is current equals dummy, and we will start with that. So current dot next is equal to list node of final dot pop of 0, basically creating a new node out of it. Current goes to current's next, and at the end you would just return dummy dot next. Fine, very simple. Let's hit run. Okay, and let's hit submit. Goes through. Yeah, as I said, hard problems need not to be solved with by messing around with the pointers. A simple approach could get you all the test cases that are there. Fine. Thank you so very much for tuning in. For more such tricks, we'll see you guys in the next video. Cheers.